Hey everyone, it's time to learn about numbers in Swift. There are three main types that we're going to discuss. One is the integer, another is double, and the last one is float. So go ahead and create a new playground. This is becoming old hat. We've done this 2 times already. And if you want, you can just keep building things in the same playground, but I find that it's kind of nice to have separate playgrounds for separate topics when you're learning. So go ahead and click on blank iOS playground, and let's call this numbers, okay? And I'm going to go ahead and make this a bit bigger, and I'll pull over this little visualizer. And this is a string, so we can actually get rid of that, and we don't need to deal with it. And we can go ahead and type a variable. And in the last few videos, we learned that variables can be used to store data that we want to change. So maybe our salary currently is $50,000, and we want it to increase. So we want it to be a variable. We want to be able to change that value. But maybe we want to use a variable for the price of a burger. Okay, maybe that will change someday. Maybe it'll be cheaper or more expensive. We're actually going to set that to be explicitly an integer. That's the type that we've dealt with before. And let's just say it's $5 for a burger. Maybe someday it'll be 4, so we'll create a variable. We could also use constants to store data that we'd never want to change or be modified, like our birth year. Okay, 1992. Or we could use explicit type declaration by maybe typing, days in a year, and we'll make that an integer. And of course, there are 365 days in a year. These are how we work with integers. We already know that from the previous video. Now, we also learned that we can use these variables and add them, subtract them, multiply and divide, just like you could in a calculator. And to show you that, I'm going to go ahead and create a variable called days alive. And I'm going to set it to be equal to the current year, 2018. I'm going to subtract my birth year, and let's see what we get. Okay, 26. That's how old I am. What I'm going to do is I'm going to select this and type an opening parentheses, and I'm going to actually encapsulate that in parentheses, and then I'm going to go ahead and multiply it by days in a year. Okay? Now, if I run this again, you'll see that I have been alive for 9,490 days. That's pretty cool. But you're probably wondering, wait, I thought that was a constant. You can't change the value of a constant. I didn't change the value. I only used it, and I used it to set the value of a separate variable. You can always use the value of constants even though you can't change them. So that's pretty cool. I just did a bit of math. Oh, and you know what? I didn't even use my birth year constant. Let's do that. And let's see if it still works. If we run it, we get the same thing. So it does. That is really cool. That's how you work with integers. Next up, we're going to learn about another type called a double. Okay? And a double is used for numbers that either have fractional bits or numbers after the decimal place. But something that you need to know is that it can be precise up to 15 digits. Okay? So that means you can be precise up to 15 points after the decimal mark, which is more than enough for most circumstances. The float is another kind, but a float can only be precise up to 6 digits. Okay, so it's a little less precise. What we can do is we can create a double by typing something like this: var intersect version equals 2.0. If you've ever watched Chuck, you'll understand what I'm talking about. But let's say that I wanted to explicitly declare this as a double. I would do it just like so. Put a colon at the end of the variable name and declare double after that. Now, if I want to use this, let's say, maybe I create a variable here called software patch, and I'm going to make that equal to 0.1. Let's say that I wanted to add the software patch to my intersect version. I could do intersect version plus software patch, and we can run it and see what we get. 2.1. So we can add values just like we would with any other type of number. So I could do 0.3. If I run this, we'll get 2.3. Very cool, very easy. So that is how we can work with numbers like doubles, and floats are the same way, but we're just much less precise. So I can go ahead and create a variable here called intersect version, and we'll set that to be equal to 1.0. Very cool. So we get a 1 in the printout. That's great. But it's going to, oh, you know what? Let's see. Let's do intersect version F for float. Something to know is that you can't name two variables the same thing. That makes sense. It doesn't know which one to refer to. So if I wanted to do something with this, maybe I would take my software patch and update the float version of my intersect as well. So check this out. Intersect version F plus software patch. And let's go ahead and let's add those together. We get 1.3, which is pretty cool. But if I look here at this intersect version, if I hold the Option key and click on it, you can see that it's being declared as a double. And Swift's type inference, if you want to use a float, you need to explicitly tell it because both numbers use decimals. So we'll change this to float, and then if we try to add them together, we'll get a crash. Okay, check this out. It'll say overloads for plus exist with the partially matching parameters float, and double. So just like before, we cannot add a double to a float. But something we can do is we can use the float's initializer and we can basically turn this double into a float. And in order to do that, we type float, and then we go ahead and put some parentheses at the end, and we can pass this into the float. And if I run it, you'll see that it works again. We have then basically taken and cast software patch as a float. We have converted it into a float value. That's another way we can work with numbers and make them work nicely with one another. Now, in order to show you the difference between doubles and floats, what I'm going to do is I'm going to add a bunch of decimal points at the end of this and then print it out. As you can see, when we actually get our value printed out, or if we go all the way through our value, we get to about here, and then it rounds the last value up to 2. If you were to count all the way through this, you would see that it is in fact 15 decimal points, and that this float value stops at 6. So there's proof that a double can be precise up to 15 digits, and that a float can only be precise up to 6 digits. Most of the time you're going to be using doubles, but there are some instances where floats are more appropriate. Now, if I wanted to create a variable here called int, and I typed int, you can see there are other types of integers as well. Int 8, int 16, 32, and 64, and this basically indicates the size that these integers can capacitate. They can capacitate up to a 64-bit value, etc., etc. Don't worry about that for now. Just know that we can use these numbers. We can use doubles for decimal numbers and fractional numbers. We can use floats for numbers that only need to be precise up to 6 digits, and we can use doubles for pretty much everything else. Swift also will identify unlabeled variables without an explicit labeling like so. If there's no label, it's going to identify it as a double. So that is something that you need to know. It's very important, and we're going to head over to the next video now, and we're going to continue learning about one final type, which is the Boolean.